Okay, guys, we're going to get ready and we're going to start our new unit of physics. Now, if you haven't done so, we need you to go ahead and save the physics notes into your OneNote. So, what I'm going to have you do again, just in case you don't remember, go to your folder, go to Everyone Shares, down to General Science, and if you look in Ritter, General Science, you hit Control C on physics, or you can hit right click copy, very similar. And then you're going to go to your home directory and you're going to save it into your general science folder. So I'd go down here and save it into general science. So I'd put it in there. And then to open it up, just remember we have to use our OneNote. So we'd go to OneNote, File, and I've already done it. So it shows up in there, Open, and you would go to your file, which is Browse, and you'd go and you'd right click and you'd open it, right? So it automatically open up in OneNote. I'll put the instructions on Moodle as well, just so you remember. But what we're going to talk about is physics. And physics is exciting because it is how everything everywhere works mechanically. It's exciting. And we're going to start about understanding frame of reference. Now, I use this all the time because you guys always are in cars or whatnot, but motorcycles. But when you're on a train, or in a car or whatever, and you're driving and you look out the window, um, you can see that the stuff moving close to you appears to be moving extremely fast, and then off in the way distance the things are moving slow. But the other thing is, think about this: the people in the car next to you, they're not, doesn't seem like they're moving at all. Maybe they're motionless, you know. And so a good example of this is you riding in the car, you're sitting next to somebody, and you're not moving. You're next to each other, but you know you're going down the road. Whereas if you look out the window, you're hauling major booty, right? So, how do we measure distance? Well, distance is essentially the length between 2 points, and we can measure that in lots of different ways. Interesting. I remember when I was a kid, my grandpa used to measure things in rods and chains, and that's a hangover from the old days, in the sense that they used chain-driven equipment. Well, we use meters in the metric system, and for very large distances, we use kilometers. But what's interesting is if you look outside or on the road, it's in miles per hour. We had a time in our country where we were trying to change over to meters, and it just didn't happen. Too many people were stuck on using the standard system, and that's okay. But lots of different countries use the metric system. Now, when we talk about simple displacement, we're talking about point to point in a straight line. Well, how often do you do that? But point to point in straight line. So if you look at page 331 in your textbook, you'll see a diagram, figure 4, and the line which is red in your book is a straight line. So and we use the term as the crow flies, right? Flies straight. Well, if you go home to school and draw a straight line, in this diagram, clearly it's cutting across people's yards and roads and whatnot, but it's straight, right? And so if you look and you measure, the distance to get to there physically might be 5. We'll just call this meters, right? But in this case, it'd be 5 blocks, right? So you could measure that out. But if you look at really what happens, distance versus displacement. So if you look at the first one, when you leave home, the yellow line, you've gone 1 block, up 1 block, over 2 blocks, up 3 blocks. Well, if you look at that, really the amount of walking that that person did was 7 blocks versus if we just went straight, which is 5 blocks. Now we don't just drive straight. I mean, the reality is we have to deal with all sorts of obstacles. And so, long and short, it's pretty easy to understand. Hey, we don't go that way. We do go around obstacles. Um, what you're going to do, and you can hit stop at any time, but what you're going to do is you're going to answer questions 1, 2, 3, and 4. 1, 2, 3, and 4 of the reviewing concepts on page 331. 331, and you're going to answer those questions. And I'll go ahead and hit pause right now. Answer those 4 questions, and then what we'll do is get started again. Okay. Hopefully you're back now and listen to this. And so we're going to keep going. So speed is awesome, very awesome, easy to understand if you understand that you change speed. So if we look at the SI unit of speed, or the metric, if you will, system unit of speed, that is, we measure that in meters per second. It's actually telling you what to do. And so when we do that, doesn't matter if you're walking, jogging, riding a bike, or whatever, we can look at that and say, okay, what is the speed of a moving object? Now, that's assuming that the speed doesn't change in the middle. So if it's a speed that you went X distance, it's the average speed, right? So it's the average speed. So in our first problem, we have 12.5 meters per second per 5 seconds. So what we would do here, and you guys can just do it with me if you want, or you just let me walk through it. 12.5, and then I would take and divide that, because if you look here where it says meters per second, it's telling you to divide that. And so take 12.5 divided by 5, and that gives us 2.5, and our units would be, again, meters per second, right? So simply dividing that out. All right, so we'll go to the next one. I'll give you a couple seconds to figure that one out. And again, what are you going to do? You're going to take 25 divided by 15. I'll give you a second to do that. Okay, hopefully you got that done. 25 divided by 15 gives us 1.6 repeating meters per second. And so, pretty simple calculation, meters per second. And we look at this sign here, and it kind of gives you an overview, right? So, kilometers per hour. And if you look at the sign on the right over here, you can see that it's showing you can go 100 kilometers in 60 minutes or 1 hour, and you can change those units. That's not a problem. All right, so you heard me talk about average speed and things like that. Some of the key terms that we talk about speed and velocity: instantaneous speed. That's at the very moment, some point that you've picked out, you can determine how fast you're going, right? Instantaneous speed. Average speed is what we did earlier, right? So we don't know if we speeded up or speeded down. We have no idea, but the entire trip, or the duration of the trip, took 25 meters per second is how long we were going. It took us 10 kilometers per hour, whatever it is. So we can figure out what the duration of that entire thing. Now, velocity, when we talk about velocity, we're now throwing a direction in there. So if I say our velocity is 25 meters per second east or west, now we have an idea of which direction we're going. And so very useful, especially when it comes to law enforcement, right? So what are they doing? Mr. Ritter, it looks like you were going 67 kilometers per hour. You're going to get a ticket. Well, if you do the calculations, I didn't get a ticket on that unless I was in a school zone or something like that. But basically, what do? We shoot a beam. It takes instantaneous speed at that moment at the car, reflects the beam back to the squad car, and then they figure out how fast you're going by the calculation. So average speed. If we take average speed, we're looking at the total distance divided by the total time, right? So makes sense, right? So how long did it take you to go X distance? And so it's more useful for us to be able to do that versus the other way of saying, okay, you were going 25 meters per second at X versus the entire trip took you 25 miles per hour, 25 kilometers per hour, or whatever. So I think it's very useful in the sense that you get the understanding of average speed is the entire time, and instantaneous speed is that moment, that snapshot, if you will. So as we do this, I like playing this little video clip from Michael Johnson's 200-meter run, which is incredible. So if you think about, as this pulls up, I'll skip the ad here. So again, if you look, his entire time to run this was 19.32 seconds for 200 meters. But, and we'll fast forward here just to kind of see what this looks like. So as you watch, he takes off from the starting blocks. Yeah, his average time, the entire thing to go 200 meters, 19.32. But it was the 50 meter to the 150 meter. He was hauling major booty, 8.6 seconds, right? So you're talking 100-meter time that was just phenomenal. And granted, he did break the world record here in 19.66. But if they look at what's even more impressive, it's that. And so as we come down, what I want to do is give you some practice problems. And this little triangle is very helpful. And so when you want to figure out either speed, distance, or time, all you need to do is put your thumb over the one you're looking for. So if I'm looking for speed, and I'll put my thumb or my cursor over the S, now all I've got to do is take D divided by T, or distance divided by time. If I want to find time out, all I have to do is put my thumb over the T. Again, now it's distance divided by speed. But let's say you want to find out distance. Put the old thumb over distance. Now we have speed times time. And again, this triangle works pretty well, and it's a great way to do it. So I'll do this first practice problem with you, and I think it'll be pretty straightforward. But we have Tom the turkey, very appropriate for our Thanksgiving dinner coming up. Tom the turkey is running away from Farmer Baum. Don't tell Mr. Baum I put him in here, but he's in here. What is the speed if he ran steady at 5 kilometers in 3 hours? 5 kilometers in 3 hours. So he ran 5 kilometers. So we're finding out speed. So we'll put our thumb over the S. We have D, in this case, D is 5 kilometers. D, so we take 5. And our time is 3 hours. Time, D divided by time, or 5 divided by 3. And Tom the turkey is running at a whopping 1.6 kilometers per hour. Pretty straightforward. Now, what I've done here is I've got a couple problems here. Mr. Faber, what is Mr. Faber's speed? By the way, that's him in this Bell helicopter. What is Mr. Faber's speed if he flew a helicopter steady for 50 kilometers for 5 hours? Right, so we're finding speed again. Let's put our thumb over the S, and we would take 50 divided by 5. Okay, hopefully you guys can get this one without using your calculator. I'll wait. Okay, 50 divided by 5. Hopefully you got 10 kilometers per hour. Mr. Faber is Really pushing the limit here. Okay, next one. Let's look at, some of you probably don't know her, but this is Miss Verdon, our former science teacher. She's awesome. So Miss Verdon travels 100 kilometers in 30 minutes. Uh-oh, we have a problem. Houston, there's a problem. 30 minutes. Now we're wanting it in kilometers per hour. So what do we need to do? Well, we need to change this, right? So we need to convert this. So Miss Verdon travels 100 kilometers. And what is 30 minutes of an hour? Well, it's 0.5. So knowing that, 0.5 hours, let's see what we got. So she travels 100 kilometers, and she does it in 0.5 hours. Her speed, I'll wait. Did you get 200 kilometers per hour? Skydiving? Oh, it's awesome. All right. The next one, let's see if we can get this. How far did Mr. Bustle chase Otis down the street? Otis is his dog. How far did Mr. Bustle chase Otis down the street if he ran for 3 meters per second for 1 hour? Uh-oh. Uh-oh. So what do we got to find out? This is in meters per second, and we want it for hours. So we have 3. How many seconds are there in a minute times 60? That's 180. And how many minutes are there in an hour times 60? Oh, so he ran 10,800 seconds. Well, now it's how far he ran. So now we did that for 1 hour. So he ran down the street, right, for 1 hour. How far did he go? 10,800 meters. We could figure that out for kilometers too. What would we do? We would divide that by 1,000, and he ran 108 kilometers. Crazy, Mr. Bustle. Mr. Bustle. All right, let's see if you can do this one. How far did Miss Buchanan and Mr. Buchanan ride if they rode steady for 4 kilometers per hour for 3 straight hours? Pretty simple. Think about it. So they were going 4 kilometers per hour for 4 hours. So we know speed. We want to know how far they rode. Speed times time. 4 times 3 gives us 12 kilometers, right? All right, hopefully you got that one. And our last one, here we go. See if you can figure this out. Miss Buchanan ran a 5K, 5 kilometers, at an average speed of 10 kilometers per hour. So we know how far they went, that's distance. We know the speed that they went, that's 10 kilometers per hour. How long did it take them to go? So D, which is 5, divided by speed, which is 10, gives us time, 30 minutes. How do I know it's 30 minutes? Because it's 0.5 hours. Wow, that's great. You guys did a good job. Now, I'm going to give you some work to work on, and hope you got this. If you need to rewind it, you can listen to it again, and we're going to work on some graphing. So thanks for listening. I hope you guys have a fantastic day and an awesome weekend.